All right, now let's take a look at some examples where we have to add and subtract these radical expressions. So first, we have 3 root 5x minus 2 root 5x. So before we can add or subtract them, we have to check, are our indexes the same and are our radicands the same? Well, these are both just square roots, so our index checks out, and the radicand is 5x for both of them, so we're all good. We can continue on with combining these terms. Next, we just have to do 3 minus 2, right? We just have to subtract these coefficients together. So 3 minus 2, that's just equal to 1. So this is going to be equal to just root 5x. Now let's take a look at the second one. We have 6x squared root 7 plus 4x root 5. So before we do anything, we have to check to make sure our index and our radicand are the same. So our index, they're both the square roots, so our index checks out. Now if we take a look at the radicand, in this first term we have a radicand of 7, and in the second term we have a radicand of 5. So we can't combine these terms. There's nothing else we can do. Right? So we can say can't combine, and that's because there are different radicands. All right, now let's take a look at this last one. 12 times the cube root of 7xy minus 8 times the fifth root of 7xy. So we have to take a look, do our check. Well, we see right away they have the same radicand of that 7xy, but if we look at our index, we see one has an index of 3 and the other has an index of 5. So that's not going to work, so we can't combine these. Right? So we can't combine because they have a different index. Now let's take a look at an example where we have to simplify before we add or subtract. If we were to just take a look at this combination right here, this expression, we would see, right off the bat, we would think, well, no, there's nothing we can do here because they all have different radicands, right? This is a radicand of 12, 75, and 3. But before we can just make that assumption, we have to go ahead and simplify each one of these roots as far as we can. So let's start with that root 12. So we have the square root of 12. We can break that down like we know how to do into the square root of 4 and the square root of 3. And while the square root of 4 can be simplified to 2, so the square root of 12, that's equal to just 2 root 3. And then we can do the same thing for the square root of 75. So we have the square root of 75. Well, that's equal to the square root of 25 times the square root of 3. And we know square root of 25, that's 5. And we can't do anything else with that root 3, so we have 5 root 3. And now we take a look. This is already a root 3. We can't do anything with that. So now let's rewrite our expression. Well, we said root 12 was equal to 2 root 3. So now we have 2 root 3 plus, we said that 75 is equal to 5 root 3. So we have 2 root 3 plus 5 root 3 minus that root 3 that we couldn't do anything with. Now if we take a look, we see that we do have like radicals here, right? We have square root of 3, square root of 3, and square root of 3. So after simplifying, we see that we can actually combine these radicals. So if we do that, now all we have to do is 2 plus 5 minus 1, and that gives us 7 minus 1. So we have an answer of 6 root 3.